Hi, my name is John McFetridge, and this is a two-part video. I'm going to be discussing in the first part ASP.NET Web API, which is a server-side technology for our backends, and this backend services are consumable across a wide range of devices. And two, I'm going Sensu-Touch will be the client we'll be using for consuming these services that'll let us write phone applications such that they can run across multiple devices, because we're doing everything in HTML5 and JavaScript. So our overall picture kind of looks like this, where we've got on the back end, we have our Model View Control Web API application, and it is going to expose RESTful methods that are going to use JSON to move data back and forth. And any of the methods that we write on our server side are going to be accessible through standard HTTP calls, such as GET and POST. And reiterating, they're going to be made available to any application that can create a RESTful proxy. Now, I'm going to be showing you tools here like Visual Studio Express, and these are and SQL Server Express. Many people seem to believe that Microsoft tools are expensive. Well, these are free. We can just go up to this Microsoft site, and for instance, we can download the Visual Studio Express for web freely, and the same is true of our SQL Express. Now we're going to dive into the individual parts. Now let's start to drill down on some details here, starting with our Web API. This is how we build our HTTP services that are going to reach this broad range of clients, from the phones to browsers, anything that has an HTTP proxy. And it works by mapping the URI and verbs to methods in the MVC Server Apps Controller. Now let's just quickly review here some terms. The MVC is, of course, Model View Control, and it's a design pattern where our model captures the behavior of the application in terms of its problem domain, independent of the UI. And the view can be any output representation. In this case, our view will be built using Sensu-Touch, because our controller is just going to be used to accept and create the JSON for that view. Now, the controller that we're going to implement the CRUD methods for our application, CRUD being the create, retrieve, and update, and delete. Now, in this case, the POST is going to be mapped into a create, the get into retrieve, and the put into an update, and of course our delete. But notice here we are following web standards, so the clients have no ties to Microsoft. A little break from the past, so Microsoft has most of their access methods have been proprietary or built around things like SOAP. As a result, these services can be hosted on any shared service or cloud service, such as Amazon. I should mention that I'm going to share some of the techniques that I've used in creating my GymPal application. GymPal has been written with Sensu-Touch in the for the views, and MVC backend with Web API. So all of the data for the machines, of course, these my domain objects here are the machines, settings, users, and the application just lets you manage the machines in the gym and build up routines. And in this case, I got this pullover machine. If my goal today is my target weight and reps, then when I do my exercise, I plug in my results. If I'm not sure what the settings are for that machine, these are my personal settings, and I can change these. It's all done in Sensu Touch. And if I want to look at, I'm not sure how to use the machine, I can even see a video. So I'm going to show you some of the techniques I use to build this application. So the first thing we do is we're now going to drill in on code, and I'm going to go into my Visual Studio Express, and this is the only tool I use. It's a free version, and I go New Project, and here I'm going to create an MVC4 web application, and we're going to call this Fit 8. Just make sure my name is unique. Hit the OK button, and now I'm going to select a web API, and the framework is going to generate a project for me, including all my models, my view and control, and these are all going to be just default items that need to be flushed out. So what it does, it actually generates a couple of controllers, and one is the values. And if we look in here, we can see the CRUD operations that were generated for us. So we'll just look at these methods. The comments show the HTTP call that will result in the method being called. If we do a get API/values, then our get method will be executed. In this simple case, we're just returning an array of strings. If we pass in an ID, we will get a specific value. In the real case, this would be the ID of an entity. And a post is how we add new entities to our repository, and the actual entity will be passed in the body of the HTTP request. And put is the way that we are able to replace, because we're going to pass in the ID of the entity we want to replace, and the body will contain the content of the entity, its new values. And delete, of course, will be is we just pass in the ID of the entity we want to remove. So what I want to make sure you understand here is that these methods that are defined in our controller, in our API controller, are consumable by any HTTP proxy. And anybody who can do an HTTP call is able to consume our services. And as an example of this, I'm going to look very briefly at two proxies. One is Chrome, and number two is a debugging proxy called Fiddler, which is again freely downloadable. Let's first of all look at Chrome. So first of all, we make sure that we have a breakpoint set in our controller, and we do, and then we go back to Chrome, and this is the default view for our server, so we know our server is running. And now we call our method just by specifying the URI, and our breakpoint is hit, and we're simply returning this to an array of strings. And if we can see the result now back in the browser. It's that simple. So we can test this now. Of course, in this case, it is XML, but it's easy to change this to JSON, because this is our required format we want to work with. So if we take this same URI and we put it into my favorite proxy debugger, which is Fiddler, we're able to, it has a thing called the Composer. In the Composer, we can put in that same URI and hit the execute. Again, you will see we're going to execute our controller method. And now if we look at we can see the return values here in Fiddler, which does a nice job of showing us our end. Fiddler will in this case, notice it is JSON because Fiddler will default to JSON, and that is again the format. Now, if your proxy did not, you just specify the content type you desire, and the Web API will return that format. Now, of course, what we've done is shown you how to call into our methods, test our controller methods using Fiddler, and write to mock code. However, we now need to look how we have a persistence layer, and in this case, our persistence layer will be a database, a SQL database. However, we're going to use the Microsoft Entity Framework. This is an object relational mapper. Hope this is familiar to some of you, that enables a .NET developers to work with relational data using domain-specific objects. And it eliminates the need for most of the data access code that we normally have to write against a SQL database using queries. And these are opaque strings that there is no type safety checking from the programming language. And the Entity Framework is much like Hibernate or Ruby in the open source world. And queries become first-class citizens in C#. They are no longer opaque strings and have type safety. Now, there's another wrinkle that they've added called code first, and this is what I'll be using here. It lets us work purely with domain objects. In this case, in our little test environment, this is our domain object, is our machine and our settings. And all the DB stuff is going to be handled by the framework. So now we're going to start to add our persistence layer to our server application. And we're going to program as if there was no database. We're going to strictly use domain objects, and we're able to do this because we're using the code first entity framework pattern. So the first thing, because I only have here two models, I'm going to add, I've already taken the liberty of adding a machine, and this machine, of course, is probably the most important domain object in my solution, and it's going to represent the exercise machine itself. We give it an ID because every entity has to have an ID, unique ID, and then just a couple properties. Then we've got a list of settings, which we call attributes. Now, this is how we create a one-to-many relationship in our object model. And the setting is we've got an ID and some properties, and this would represent something like the results the user has on that machine, like the reps and their target weights. So we define our domain objects here. We go over to our controller, and we're going to add a new controller, and called machine. We're going to take the default as an API controller that is going to use the entity framework. And the model class, we only have two models. One is our machine, grab the machine, and the data context, it happened to default to the right name. The data context is simply the code or the widget that is going to let us work in our object, in our domain objects, and then the context is going to handle the persistence to our database and the retrieval. Now we want to put some test data into our database so we can start to work against some real data. Now, of course, as I said earlier, the data is stored in our database, but all our access is through objects, and this is the magic of the code first entity framework. So I first changed my connection strings so that I point to SQL Express because I just want to show these changes in a database. Now, remember, again, SQL Express is free, and the connection string is just where how we're going to connect to our database. and the initial catalog we're going to create is called Fit9. So the first thing we do to create data, I get down, I bring up something that is called the, under other windows, we will see the Package Manager console. Now here, we have to actually enter a console command, and the first thing we do is do enable migrations. So migrations are simply so that we can keep our objects in our database in sync. Now you don't have to do this, you can manually do it, but this is just the programmatic way to do it. Now we will see we've got a new folder over here called migrations. And migrations got a file called configuration, and we want to make sure that the migrations are on by default, and that we're going to supply seed method. The seed method is simply a way we can take by through our objects, we can populate our database. So now I just cut and paste some code that will seed our database using C# and no database calls. In here, we create 3 machines, machine 1, 2, and 3, and then each machine will have a list of attributes, and this is where we define our one-to-many relationship between the machine and the settings using objects. Then I will define settings such as weight, and each of these settings I will add to the attribute list in the individual machine. Now, and finally, I will call the add method of our data context, because what we're doing, we're adding our machine to this DB set of machines, and then the data context is going to be responsible for taking and persisting our changes to the database. So we never have to write any SQL code. It's all done for us. Now to execute this C command, we again go down to our Package Manager console, and we use the update database call. And this should take and persist our data into our SQL Express database. And it says we did run the seed method, so let's make sure. We'll just bring up SQL Express, and in SQL Express, we're able to, if I do have a FitD database, and if I refresh my tables, and then I open up my machines, we will and select the top 1,000 rows, you will see that indeed we have put the 3 machines into our database. And similarly, we can go in and look at settings and see that we have put 4 settings. Now, there's one interesting column here. That's the machine_machine ID, and this was produced by the one-to-many relationship we define between machines and settings, so that machine ID, the weight and S are going to be associated with machine 1, and H and var2 will be associated with machine 2. But all that code was generated for us. Now we've got sample data. Let's again look at our API with Fiddler. And our first call, of course, is going to be our get, and here we're just getting the list of machines from our object set. And if we go into bring up Fiddler and go into Composer, in Composer we'll just make the call get our list of machines, and then we get back our HTTP call is made, and we look in here and we see our JSON. And notice in our JSON here, we've got the 3 machines that are in our database, the leg extension, the leg curl, and the pullover. Now, but notice that the attributes is null. And the reason is the way that the entity framework works is that by default, everything is lazy loaded. So that means unless we are explicit and we tell it to include our settings, they're not going to be loaded until they're requested. So we have to stop our server and do an include, and this time we'll say include s and s dot attributes. Now this is those who are not used to C#, this is what's called a lambda. And this lambda expression just simply says to include the attributes. And now if we rerun this and we go back into Fiddler, we go back into Composer and make the same request here, and we look at our response. Notice, so now we see not only are we bringing back our primary properties, but we're also getting the list of all the attributes. So now we can also use Fiddler to test our post. Remember, the post, we're going to be just passing in a new instance of a machine. So we're just going to grab some from our last get. We will just grab a machine definition here so I don't have to type in all the JSON, and go back to Composer, and Composer change my verb to a post and remove the content length, and we're going to pass the new machine will be passed in the request body. And if we hit the execute, we will see that we are now in our post method in our web API server. And if we look at machine, this is what we now, our client are of course simulated and created. I just slightly here changed the definition of the get with an ID, and just to show you that how you can build up these entity framework queries this kind of the same way you would in SQL. Like for instance, that there is the where clause, and if on where we have one parameter here where the machine ID is equal to the ID that we passed in. And of course, if we happen to spell ID wrong and say ID 1, the compiler would help us and tell us we made a mistake. And so it's no longer an opaque string, we're just passing into SQL Server. And this, if this throws an exception, meaning we don't find it, then we're going to create an HTTP status code, and we're going to send this response of not found back to our client. So if we walk back over to Fiddler, and we go back into the Composer, and we change our verb back into get, and we'll say machine slash 5, or let's make it work the first time and say 1, and now we should see the same as result as we had before, and we return the leg extension. However, if we walk back up to our Composer and we say machine equals machine 9, which does not exist, then our response should be a 404. And we're now stuck in our debugger, so we need to continue, and then we will get the 404 back in our client. Now, now I think I've shown a few things here. I can show you that that this web API has got absolutely nothing proprietary to Microsoft. I mean, the tools are, but the result is a server that can be consumed by any HTTP proxy, and this can be a browser, phone application, or it can be Fiddler. And I've also shown you that how valuable to a Fiddler can be in helping to develop and debug your web API server, because it is an HTTP client. Then I've showed you some parts about Entity Framework, and in particular the code first, and the value of it in doing domain-driven development, because we're going to be working exclusively with domain objects and really no sense of a database. So these, and of course the domain model I use is very simple, a subset of what I use in my real GenPal application. However, we're now going to move on, and we're going to use a real client written in CenturyTouch to consume this web API.